Hello, everyone, and welcome to Glen Forest Academy, the home of mathematics, statistics, and science. Before we get started, if you would like to leave a comment or make a request, kindly follow the link that is provided in the description box below. Right. This is the first actually in a series of videos that is going to be digging deep into calculus. And the first topic that I've chosen for the video, for this particular video, is the epsilon-delta definition of a limit, which is also known as the precise definition of a limit. Now, obviously, for you to be able to understand what is going on here, you need to recap the definition from your textbook. So I have summarized it here as follows. So we have the statement limit of the function f as x approaches a equal to L. Now, what does it mean? It means that for any epsilon, we have a delta such that for all x in the domain, with x minus a less than delta, we have the absolute value of fx minus L less than delta. So this is more of an if-then type of statement. So now, the example that we want to look at is this particular one, where we want to prove. So basically, we want to prove. So let me just say RTP. RTP stands for required to prove that the limit of this function, which happens to be a linear function, 3x minus 5 as x is approaching 4 is equal to 7. Now, the way we go about it, so we already know that we are dealing with an if-then type of statement. So in order to do the proof, we need to follow a series of steps, two in particular. The first step is not the proof itself, but it is just a way of finding our delta. Because remember, in the definition, we are required to find delta. So the first step is where we are trying to find delta. So let's get started. So we start by writing this statement, fx minus L, which is less than epsilon. So what is our fx? Our fx is 3x minus 5. And minus L, what is our L? Our L is 7. And all this is less than epsilon. So now, a little bit of algebra. Minus 5 minus 7 is minus 12. So this gives us 3x minus 12 less than epsilon. We see we've got a common factor here. So we can factor out the 3. And that will give us x minus 4. Now, while we are here, pay attention that our x is approaching 4. So what we know is that we are aiming for x minus 4. That is where we are going to get to x minus 4 less than delta. Now, so that means the x minus 4 is the thing that we really want. So we need to isolate it by dividing both sides of the inequality by 3. So remember, 3 is positive. So we keep it positive. But because we know that 3 is positive anyway, we can drop the absolute value sign. So, and then we get here. Now, dividing both sides of the inequality by 3 gives us x minus 4 less than epsilon over 3. And this is our delta. So you can see clearly that resembles that statement above. That is what we wanted to do. We wanted to arrive at x minus 4 less than delta. So that means our delta, we can choose epsilon over 3. Now, the next step now is the actual proof. So let's do the proof. And we always begin writing by the proof by stating the following. So we say let epsilon be given, then choose delta to be what? Epsilon over 3. Then we have the following. So, right. So in this step now, it's a reversal. So this, in the previous step, we started off with fx minus L less than epsilon, and we ended up with x minus 4 less than delta. Now we start off with x minus A less than delta, which is actually x minus our A, remember, is 4 less than our now chosen value of delta, which is epsilon over 3. And again, we go through a series of steps, algebraic steps. So we've got a denominator 3 here, so we can multiply out the both sides of the inequality by 3. So that'll give us, right. But remember, we are trying to get back to this step here. This is where we are going. So now let's see whether that is going to be possible. So we multiply out, then we have 3x minus 12 less than epsilon. And of course, minus 5 minus 7 as before gives us minus 12. And now we can rewrite this as 3x minus 5 minus 7 less than epsilon. And voila, we got there. Because basically our aim right from the beginning was to arrive at what? At fx minus L less than epsilon. And friends, this completes the proof.